Every second, without you even realizing it, our planet is racing through space at nearly 30 kilometers per second. The sun carries our entire solar system around the center of the Milky Way at more than 800,000 kilometers per hour, and the Milky Way itself is drifting through an expanding universe filled with countless galaxies. At this very moment, as you're watching this video, Earth is traveling through one of the greatest mysteries ever known. Somewhere out there, another civilization could be looking up at its own night sky, wondering exactly what we're wondering right now. Are we alone? For thousands of years, humans believed Earth was the center of everything. We thought the sun revolved around us, and beyond the stars lay only mystery. But every scientific discovery changed that picture. We learned Earth was just one planet orbiting an ordinary star. Then we discovered that our sun was only one among hundreds of billions of stars in the Milky Way. And eventually, we realized that our galaxy itself is just one among hundreds of billions, perhaps even trillions, spread across the observable universe. Suddenly, humanity's place in the cosmos became incredibly small. Earth didn't seem like the center of creation anymore. It felt like a tiny island floating in an endless cosmic ocean. That realization led to an unavoidable question. If the universe is so unimaginably vast, why does it seem so empty? Why haven't we found anyone else? For centuries, this question belonged more to philosophy than science, because we simply didn't have the technology to search for answers. Astronomers could observe distant stars, but they had no way of knowing whether planets even existed around them. It was entirely possible that our solar system was unique. Then, in 1992, everything changed. Astronomers confirmed the first planets orbiting another star. It was one of the most important discoveries in modern astronomy. Since then, our understanding of the universe has transformed completely. Today, scientists have confirmed more than 6,000 exoplanets orbiting distant stars, proving that planets are not rare at all. They are everywhere. Some are massive gas giants larger than Jupiter, while others are rocky worlds similar to Earth. Some are frozen wastelands, others are scorching infernos, and many orbit within what scientists call the habitable zone, where temperatures could allow liquid water to exist. Water is one of the most important ingredients for life as we know it. Every organism on Earth depends on it. So naturally, astronomers began asking a new question. Instead of wondering whether planets existed, they started wondering which of these worlds might already be alive. Imagine holding a handful of sand at the beach. Every grain represents an entire solar system. Even then, you wouldn't have enough grains to represent all the stars in the observable universe. Scientists estimate there are more stars in the universe than grains of sand on every beach on Earth combined. If only a tiny fraction of those stars have planets capable of supporting life, there could be trillions upon trillions of potential homes for living organisms. Statistically, it almost feels impossible that Earth is the only planet where life ever appeared. But science isn't built on probabilities, it is built on evidence, and for decades we had none. Everything changed again when humanity launched the James Webb Space Telescope. Unlike previous telescopes, Webb wasn't designed simply to capture beautiful images of distant galaxies. It was built to analyze the atmospheres of planets hundreds of light years away. Whenever a planet passes in front of its parent star, a tiny portion of the starlight travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light, creating a unique chemical fingerprint. By studying those fingerprints, scientists can determine which gases exist in an atmosphere without ever visiting the planet. It's one of the most remarkable achievements in modern astronomy. Among the thousands of known exoplanets, one world immediately captured scientists' attention. Its name is K2-18b, located approximately 120 light-years away from Earth. It doesn't resemble our planet. It's much larger, covered by a thick hydrogen-rich atmosphere, and scientists believe it could belong to an entirely new class of planets called Hycean worlds, ocean-covered planets hidden beneath deep hydrogen atmospheres. If these oceans truly exist, they could provide environments where life might survive. Then came the discovery that made headlines around the world. Using the James Webb Space Telescope, astronomers detected methane and carbon dioxide in K2-18b's atmosphere. These molecules alone do not prove life, because geological processes can produce them naturally. However, hidden within the data was a much more intriguing possibility. Scientists found a weak signal that could represent dimethyl sulfide, or DMS. On Earth, almost all atmospheric DMS is produced by microscopic marine plankton. If DMS truly existed in the atmosphere of another planet, it would become one of the strongest biosignatures ever detected beyond our solar system. For a brief moment, many people wondered if humanity had finally discovered evidence of alien life. But this is where science separates excitement from evidence. The possible DMS signal was extremely weak and has not been confirmed. Researchers themselves emphasize that more observations are required before anyone can claim it is actually present. In science, extraordinary claims require extraordinary evidence. That's why astronomers carefully distinguish between what they know and what they suspect. So here's what we know today. Fact. The James Webb Space Telescope confirmed methane and carbon dioxide in K2-18b. Fact: K2-18b could be a Hycean world with conditions that may support liquid water. Theory: dimethyl sulfide may exist there, but it has not been confirmed. Unknown: whether life actually exists on the planet. That distinction is incredibly important because throughout history, nature has repeatedly shown that non-living processes can imitate the chemical signatures we often associate with life. Yet K2-18b is only one small piece of a much larger puzzle. Every year, new observations reveal more planets, more atmospheric chemistry, and more potential places where life could exist. For the first time in human history, we're no longer asking whether other worlds exist. We're asking which of those worlds deserves our closest attention. And that's where the mystery becomes even deeper. If planets are common, if water may be common, and if the basic ingredients for life exist throughout the universe, then intelligent civilizations should have had billions of years to emerge before us. The universe is nearly 13.8 billion years old, while Earth formed only about 4.5 billion years ago. If even one civilization began a billion years before humanity, it could have developed technologies far beyond our imagination. It could have explored the galaxy, built enormous structures around stars, or left behind unmistakable signs of its existence. So why don't we see any of them? Where are the alien civilizations? Where are their signals? Where are their cities? Where is everybody? This simple question, famously asked by physicist Enrico Fermi, became one of the greatest unsolved mysteries in science. Today, we know it as the Fermi Paradox. And once you truly understand this paradox, you'll realize that the silence of the universe may be even more mysterious than the possibility of aliens themselves.
If the universe is old enough for intelligent civilizations to exist, then perhaps we've been looking for the wrong kind of evidence. For decades, scientists searched the skies for radio messages, imagining that an alien civilization might communicate the same way we do. But what if a civilization millions of years older than humanity no longer relies on radio at all? Think about our own technological progress. Just 100 years ago, radio transformed civilization. Today, much of our communication travels through fiber optics, satellites, and digital networks. Technology evolves quickly, so if another civilization had a million-year head start, their technology might be completely invisible to us. This idea inspired physicist Freeman Dyson to propose one of the most fascinating concepts in astronomy. Instead of searching for messages, perhaps we should search for engineering. Every advanced civilization would eventually face the same problem: energy. As technology grows, so does energy consumption. Eventually, the energy available from an entire planet would no longer be enough. The obvious next step would be to harvest energy directly from the civilization's star. This hypothetical structure became known as a Dyson sphere. Despite its name, scientists don't imagine a giant solid shell surrounding a star. A solid shell would be gravitationally unstable and almost impossible to construct. Instead, modern researchers believe an advanced civilization would most likely build a Dyson swarm, millions or even billions of satellites orbiting the star, each collecting a small amount of solar energy. Together, these satellites could capture a significant fraction of the star's power. Other concepts, such as Dyson bubbles supported by radiation pressure or nested matryoshka brains, remain theoretical ideas for civilizations far beyond our current capabilities. The fascinating part is that we might actually be able to detect such structures. According to the laws of thermodynamics, no machine is perfectly efficient. Every civilization, no matter how advanced, would generate waste heat. A star surrounded by enormous energy collectors would appear slightly dimmer in visible light while emitting an unusual amount of infrared radiation. Astronomers have searched for these unusual infrared signatures using space telescopes like IRIS and WISE, but so far no confirmed Dyson megastructure has ever been found. That doesn't mean advanced civilizations don't exist. It simply means we haven't found convincing evidence yet. But the universe has given us something else, something far stranger than silent stars. In 2007, astronomers discovered a signal unlike anything they had ever seen. It lasted only a few thousandths of a second, yet during that brief instant, it released an astonishing amount of energy. These mysterious flashes became known as fast radio bursts, or FRBs. Since then, hundreds have been detected arriving from distant galaxies, billions of light years away. Some occur only once and disappear forever. Others repeat unpredictably, as though something in deep space is switching on and off. At first, nobody knew what could produce such incredible bursts of energy. Some speculated about colliding neutron stars, others suggested black holes, and as expected, many people wondered whether they were signals from alien civilizations. The idea captured public imagination because the bursts were so unusual. But science requires evidence, not excitement. The strongest explanation today points to one of the most extreme objects in the universe, a magnetar. Magnetars are a rare type of neutron star with magnetic fields trillions of times stronger than Earth's. When these magnetic fields suddenly rearrange, they can release enormous bursts of energy, including powerful radio waves. In 2020, astronomers observed an FRB originating from a magnetar inside our own Milky Way, providing the first direct evidence that magnetars can indeed produce fast radio bursts. Yet even this explanation doesn't solve every mystery. In 2024, researchers trace one repeating FRB to an ancient elliptical galaxy where almost no young stars exist. Magnetars are usually associated with young stellar populations, so this discovery challenged existing models and suggested that more than one type of cosmic event may be responsible for these signals. Once again, the universe answered one question while creating several new ones. But perhaps the strangest radio signal ever detected wasn't an FRB at all. On the night of August 15, 1977, a radio telescope known as Big Ear recorded an incredibly strong narrowband signal lasting exactly 72 seconds. The signal appeared near the natural hydrogen frequency, an important frequency many scientists believe would be an obvious choice for interstellar communication because hydrogen is the most abundant element in the universe.